Yay, we didn't miss too much. Okay, so this is our introduction to systems of linear equations. So here's this little scenario. Joe is investigating offers to purchase t-shirts. What questions, well, basically, we're trying to figure out which of these is like the better offer. So like quality tees or terrific. And so we're gonna start off, what types of questions would you like ask to help her choose the best offer? And you can just write down a couple.
Yeah. For the best offer, it's focusing on the price because that's all you're given at this point.
Yeah, the price. Wait, Shawnee, you tell me when it's time to move on, because I can't see anything.
Okay, I don't see any real answers in the chat, you know?
No, it's not in the chat. It's in like the Desmos thing.
Yeah,
It's like you go to Desmos and you go to T. I just don't want to show everyone's answers to the whole class. But I guess I can do it one time. So you click on teacher, and then you can see all their answers. Which one? How many shirts do you want? How many t-shirts are you buying? How many t-shirts are being bought? Are you looking to save money? How many t-shirts are you planning on buying? How many shirts do you want? How many t-shirts do you want?
You could just put anonymize on so then you won't know.
Oh yeah. Okay, that's a good idea. Jill's codename for notable mathematicians. Okay, Dan. Okay, whoops. Oh shoot.
Okay.
There's a thing at the top of my screen, so I can't move it.
Yeah.
I can't get back to my old tab.
You can minimize the browser and then
There. Okay.
Okay, so basically, the two questions you want to ask is how many shirts are you buying, and how much will it cost in the end, right? So which one costs less, given how many shirts you are buying, right? So for example, if if I wanted to get like 6 t-shirts, right? Then for quality tees, it would be 6 times $6, which is 36 plus the design fee, right? Which is equal to $66, right? And then if I wanted to buy it from Terrific, right, I would have 6 times 8, which is 48 plus 20, which is $68. So quality tees would be like better in this scenario because it would cost less, right, than Terrific, even if it's by a little. So we would want to know how many shirts they're going to buy just so we know which one will cost less.
Okay. So say Joe needs to buy 10 t-shirts for like a field trip or something. So which one would be better, quality tees or Terrific?
Also, just a thing to note, the design fee is like a flat fee. Like no matter how many shirts you buy, you will only pay that amount plus how much it costs total for a shirt, right? So
Wait, Shawnee, are you admitting people?
yeah, I am.
Okay, that's good because I realize I haven't been doing that.
Yeah. Okay, I think a lot of the kids have answered. 7 of the kids have answered.
Yes.
I can explain. So basically, same thing as before. We want to know how much it'll cost total for each of the stores to buy 10 t-shirts. So for the first store, it would cost 6 times 10, which is 60, plus $30, right, which is $90 for quality tees. However, for Terrific, it would cost 10 times 8, which is 80, plus $20, which is $100, meaning that Terrific costs more, so quality tees is the better choice in this scenario. So everybody who answered got that's a good job.
Oops. Dang it. Let me try to clear that off. Okay. So now let's graph what this scenario would look like so basically we're going to have the number of t-shirts on the x-axis and we're going to have the total.
I don't think you can access the slide.
Oh, sorry. Okay, there we go. You should be able to move forward now. So the number of t-shirts is going to be on the x-axis and the total cost is going to be on the y-axis. So just fill in the table and then like look at the relationship that is graphed. Oh yeah, we can put the link. You just go to student.desmos.com.
I just put the code in the chat again. So
Yeah, and then you type in that code.
no problem.
Ooh.
Yeah.
Oh, wow, you don't even need to calculate it.
Amy, wait.
Yeah.
Wait.
Do you want me to not fill in the rest?
Yeah.
Okay.
Actually, I think most kids are finishing up.
Interesting graph.
Mhm. You can click overlay if you go to the teacher tab, and then you can see like everybody's.
Oh, okay. You really know this, Desmos. Okay. Okay, do you want to go over now?
Yeah.
Just saying there's probably a way so that you can see the names, but we
Yeah, there
can't.
is.
Okay.
It's just that since I'm sharing my screen, everything on my side is going to appear on in the meeting, and so yeah. Okay, so to fill in the table, we just plug in the number of t-shirts into the scenario. So quality tees produce t-shirts for a $30 design fee, which means that there's always going to be $30 plus $6 per each t-shirt. So let's just call the number of t-shirts N. So then we just plug that in. So for 0 t-shirts, it would be a $30 design fee plus 6 times 0. So that would just be 30. Then for 5 t-shirts, it would be the $30 design fee plus $6 times the 5 t-shirts. So that would be 60. And so for 15 t-shirts, it'd be $30 plus 6 times 15. For $18 it'd be 30 plus 6 times 18. And then for 30 t-shirts, it'd be 30 plus 6 times 30 dollars in total. So this shape, I guess, is a line because this is a linear equation. We're modeling the relationship between the number of t-shirts and the total cost. So if we graph it, it will give us a line.
And the reason it's a linear is because like the rate of change, which is the $6 charge per shirt, remains constant, meaning that there's a constant slope, meaning that it's always going to have like a slope of 6 in this scenario, right? And you can see that when you calculate it, right? If we take the points like 5 and 0, but the x coordinates of with the number of shirts that's 5 and 0, we can see that y1 minus y2 over x1 minus x2, which is the formula for slope, is 60 minus 30 over 5 minus 0, which is equal to 30 over 5, which is just 6, right? And that shows that that's our rate of change, which is the $6 charge per shirt. So like whenever you're gonna have it like some sort of scenario like this, whenever it's like per something, right, that's always gonna be slope, unless it's just like trying to confuse you. Yeah, so because per unit, where the unit is the thing you're inputting, right, that will always be the slope. So
Okay. Oh wait, I just gave you the answer for this. Oops. Okay, write a linear equation that expresses the total cost of a certain number of t-shirts in terms of the number of t-shirts, which is kind of what I wrote on the previous slide. So, yeah.
okay, I think most people are getting it. There's one
Yeah.
weird answer where it's like not right.
That's okay.
Yeah, like it's y to the 4th plus 748.
That's probably just a mistake.
Or yeah, sure. Yeah. Okay, remember everybody that this is the linear, meaning it won't have any exponents and like the variable. So yeah, just keep that in mind.
Yeah. So, once again, the slope is 6 because it's $6 per shirt, and there's an initial design fee of $30. So this is the equation. Okay, now let's look at the other t-shirt design company. Terrific produces t-shirts for a $20 design fee plus $8 per shirt. So you'll notice that Quality Tees has a more expensive initial design fee, but each subsequent t-shirt is cheaper. Compared to Terrific, they have a cheaper design fee, but each t-shirt costs more relatively. So just fill in the table. And I'm going to stop sharing for a moment because I need to turn something off. Whoa, you guys are fast.
I just copied to the equation and just replaced it. So
I mean, yeah, that's pretty much what you do.
yeah, but like since it calculates, it's not that hard.
Yeah.
By the way, Amy, if you click the, so your own teacher, so if you click show correctness,
Yeah, I know. It'll be like yes or no.
right? So,
But that's it. But a lot of times it'll just be X because they haven't finished it. So,
right.
do you want me to go over it?
Yeah.
Okay. So again, there's initial design fee of $20 plus $8 per t-shirt. So for 0 t-shirts, it'll be the $20 fee plus $8 for 0 t-shirts. So that would just be 20. For 5 t-shirts, it'd be $20 plus $8 for each of those 5 t-shirts. So that would be $60 in total. So for 15 t-shirts, it'd be the $20 design fee plus $8 for each of the 15 t-shirts. So that would be $140 total. For 17 t-shirts, it would be $20 plus $8 for each of the 17 t-shirts, which is $156 total. And for 33 t-shirts, it's the $20 design fee plus $8 for each of the 33 t-shirts, which is $284 total. Once again, there we have this cool line that represents this $20 design fee plus the $8 per t-shirt. Now the slope of this line here is a little bit steeper than the previous line because each shirt costs more for terrific compared to quality t-shirts. So this line would have a steeper slope. Okay, so now write a linear equation that represents this line. Also, this the way you graph these points and then like connect them to form a line, this has really good real life applications. I was just doing it today for something, and I could maybe show it if Ishani, I could show it
Yeah,
maybe.
you can.
It's pretty cool. I won't show it now though. It's just if we have time, then we could do it for fun.
Yeah, like before we do the Kahoot.
Yeah.
We do. Yeah.
Okay, I'll go over it now. I think all of you guys got it right. So y equals the $20 design fee plus $8 per t-shirt. That's it. Okay. So yeah, you can do
After
it.
writing an equation for each of the t-shirt companies, Jill wrote this equation. Why do you think she wrote that? So basically, what does this equation represent in this scenario?
Wait, what? This is not. Wait, oh. Wait, Shawnee, is that you?
Yeah.
Okay. I wasn't using the built-in annotation. I was doing the Google Chrome annotation.
Oh, well,
Now I can't. Okay. I'm just going to use the Google Chrome one because. Okay. It's not as colorful though.
yeah, true.
Ooh. Okay. Okay.
Okay,
So here's some. Oh, you can do it.
Sorry. Okay. So basically it's setting both of the equations that we found earlier equal. So that would mean that we are trying to find where where it's equal. So we're finding where y for both of them are equal, right? And y in this scenario represents, or y in both of the equations had represent the total cost of the t-shirts. So therefore, this is finding where the total cost of the t-shirts is equal. It's right. Yeah. Okay. So I think a lot of you said that.
Yeah, I saw some answers. It's showing the total is find the intersection of the two lines when the cost and the amount of t-shirts are equal. It means how many shirts Jill has to buy in order to pay the same amount of money to both companies. Yes, it is like the equal value method. How many t-shirts would cost the same for both companies? Yeah, so you guys pretty much get it. So now solve this equation. And what does the solution tell us about the t-shirt offers? Which, I mean, I think we basically just told you what the solution means, so you can just solve it.
Okay, I think most people are getting it, so I shall solve. So we have an equation here which we can solve. So we have to isolate the x, meaning we have to get x on one side and else on the other. So we subtract 6x from both sides, and we get 30 plus, or sorry, not plus, right? 30 is equal to, screen just changed. Okay, yeah, equals 20 plus 2x, right? And we subtract 20 from both sides because again, we're isolating the x. So we get 10 is equal to 2x, meaning that 5 is equal to x. So that means that so because x is the number of t-shirts she buys, right? That means, wait, yeah, x is the number of t-shirts she buys. It tells us that when we are charging $5, when we get $5, or when we pay for 5 shirts, we have the same cost. So this would be the point where terrific and quality tea switch places as to which one is the best offer.
It would also be the place where the two lines we graphed, that's where they would intersect, because when they intersect, the x and y coordinates are the same, which means that it's the same number of t-shirts, but they also cost the same. Okay, apparently Jill is famous for buying t-shirts because she receives a flyer from a third company, Best Tees, whose information is shown by the black line. So the blue line is terrific, which we already graphed, and quality tees is the red line, which we already graphed. And this is the black line's Best Tees. So what advice can you give Jill for choosing a t-shirt offer? So in other words, which company should she buy the t-shirts from and for which number of t-shirts? And as a hint, look at the intersection points. That might help. Sorry. Ishani, do you want me to go over it now?
I can go over it.
Okay, you can go over it. Oh,
So yeah.
okay.
So Jill, so we can see from this graph on the left that if Jill is buying from somewhere, right, then the Y value is the total cost. And we want the total cost to be the least amount that it can be, right? Because we want the cheapest thing. Like think about like if you're going to the store, you want the lowest price, right? Or your parents do, right? So you would try to get the one that has the lowest cost. So we can see that up until 5, right? So when X is 5, so when she's buying 5 shirts or less, that shows terrific is the best option, right? So we can write that on the right, right? So if Joe wants to buy 5 t-shirts or less, then terrific, right? Which, yeah. Okay. And if Jill wants to, and after 5 shirts, we can see that the lowest cost up until around how much is that?
Somehow
Around
50?
52.
52?
Or it's probably 50.
Yeah, it's 52.
Right? Okay, yeah. So at 52 shirts, if she wants to buy 52 shirts to 55 shirts, so between 5 and 52 t-shirts, exclude or not exclusive, right? 5 and 52 t-shirts, she should buy from a quality t-shirts because that has this least price. Otherwise, she should buy from Best Tees because after you buy 52 t-shirts, Best Tees will always be the least because if you think about it, the other lines are going up really quickly compared to Best Tees. So it will always be the best option after that. So that is pretty much the advice you should have given Jill.
Do you want to do the last one or do you want to just move on?
What?
Do you want to do the last slide or do you want to just move on to something else now?
We can move on.
Okay. Okay, hopefully you guys now have a good understanding of systems of equations.
And if you don't, feel free to ask any questions you have.
Okay. So, okay. Well, what we just introduced was basically just systems of equations. It's basically when there's 2 or more equations that share the same variable. So, for, like what we just did, we had the variable x represent the number of t-shirts, and the variable y represent the cost of those t-shirts. And sometimes in other equations, a different number of variables can be given. So, for example, one equation might say a plus b plus c equals 12. And another equation might say 3 times a equals b. And a third equation might say c equals 2 times the quantity b plus 1. This is a system of equations with 3 variables. It's a little bit harder to solve, and I don't think we're going to solve those today. But you can see how in the first equation there are 3 different variables, but the second one only had 2 variables, and the third one only had 2 variables, but this whole system still had 3 variables in it. So there are 4 ways to solve a system of equations. And the first way is to graph it, which is what we just did. To solve a system of equations by graphing, you just graph the lines and then find where they cross each other. So if this is a line and this is a line on like some coordinate plane, then this would be the solution to the system, this point right here, because that's the point of intersection. Just to note though, sometimes there will not be a solution, because if the lines are parallel, then, well, they'll never touch each other. There's no solution.
Or in other contexts, a solution might not make sense. For example, if we had like 2 lines here, right, and they intersected in the second quadrant, right, and it was on price, right, like where the x-axis is the number of things you're buying and y is like the price, you can't buy a negative amount of things. So like it wouldn't make sense in certain contexts, even if the lines would intersect. So yeah, word problems can screw that up.
Yeah. Second way to solve is substitution. And just to put it quickly, it's basically where you take one expression in terms of the other, and then you substitute that into the second expression wherever that variable is present. So the y here would become this squiggly mess. We'll go into more detail later. The third way is called elimination. And this way is interesting. Basically, for this way, you either add or subtract the equations from each other, and that makes one of the variables disappear, because then you just have one equation with one variable, and hopefully you can do that. So elimination just gets rid of one of the variables when you subtract or add an equation. And the equal value method is where you have 2 equations, say they're both set in terms of y. So y equals something and y equals something else. Since we know they're both equal to y, then that means the expressions must be equal to each other. So we can say one expression equals the other expression and solve. So that's a brief overview. We'll go into each of these in more detail. Okay, Shani, you can do this.
Yeah, okay, wait. Sorry, I'm just trying to clear my drawings. Okay, so graphing. So graphing is the first way that we are covering on how to solve. So when we saw in Desmos, we can graph the system of equations to find where the lines intersect, right? So an intersection point is the solution. Oh yeah, you can X out of the Desmos thing. However, when there are more than 2 variables, it's difficult to graph, mostly because you need like more than just a coordinate plane. You need like a 3D plane, and when there are like 4 or more variables, you can't really have like a 3D plane or whatever, right? So this solution can be helpful when you're visualizing certain like problems, but it isn't the most practical, because you're gonna have to actually like graph out something like on your paper, and that'll be difficult and time consuming, and you probably aren't going to like draw it to scale. Like your drawing skills are not that good, you know, to like have it perfect. So it
The voice is kind of faint for me.
what?
Yeah, your voice is a little quiet sometimes.
Oof. Okay, sorry. I shall try to speak up. Okay.
Okay.
So number 2 is substitution. So it's where we find, so we're given an expression and it's equal to a variable. So we substitute for that variable and then other with that expression. So for example, in this scenario, we know that 2x plus y is equal to 5, and we know that y is equal to 8x. So we can plug in that y value into the first equation. So we would get 2x plus, and then y is equal to 8x. So 2 plus 8x is equal to 5, right? So now we would get 10x is equal to 5, which would mean x is equal to 1/2. And that would mean that y is equal to 4, which we use to find a coordinate point of 1/2 comma 4. So that is substitution. And then the third method is, so for substitution, you need to organize your steps. So you can't set one of the variables equal to an expression. Sorry, you set one of the variables equal to an expression, and that expression cannot have the variable itself, because you can't exactly like have like, if you have y is equal to 2x plus y, you can't plug that into something else, because you're still gonna have that y variable, right? And it wouldn't really be helpful. Step 2, you substitute the variable into the other equation with the expression, and then step 3, you simplify and solve if possible. And if possible means like it would have to be, there's an intersection there, right? It can't be parallel. And then you repeat the process if necessary if there are more than 2 variables, and you solve for all variables. So example 1. Okay, yeah. Solve using substitution. 4x is equal to 8 times y minus 1, and y plus x is equal to 13.
And put your answer in the chat. Shawnee, do you want me to solve or?
I can solve it, and then you can do example 2.
Okay.
Okay. So solve it using substitution. So you could either set the second one as the way to substitute, right? So you'd have like y is equal to 13 minus x, or x is equal to 13 minus y. Or you can use the first one to substitute. I would personally use the first one because it would be like less it just requires you to divide by 4 and then plug it in, and also it's the first thing that comes there. It's the first equation. So first you divide both sides by 4, and you get x is equal to 2 times y minus 1, right? And that we can plug into the second equation, and we get y plus 2 times y minus 1 is equal to 13, right?
Oop.
I think you
Wow.
like just accidentally revoked my writing privileges.
I didn't revoke it. I was trying to click the rectangle button.
Oh, right. Okay. Well, so we had x is equal to 2 times y minus 1, right? So we plug that in, and we get we plug it in for x, and we get y plus 2 times y minus 1, which can also be just 2y minus 2, right, is equal to 13. And then we just, on this point, we just like combine like terms and then isolate the variables. So we get 3y minus 2, so we add 2 to both sides, and we get 15, right, because minus 2 plus 2 is equal to 0. So we get 3y is equal to 15, so that means y is equal to 5. So therefore, we can like plug that into the second equation, and we get x is equal to 8. So yeah, that is how we solve.
Okay, second example, solve using substitution. Or actually, do you want to go on? Because,
Yeah, we should probably.
okay, yeah. Oops, that's not what I meant to do. Oops, gosh. Okay, sorry. Elimination is the third method. It should be third method. So basically, as the name suggests, we're eliminating or removing the variables until there's only one left, so we can solve. So for elimination, you need to do a little bit of manipulation. So you need to change the equation a little bit before you can do elimination. So to do this, you can multiply the equation by both sides by a constant, or like add the same thing to both sides to change the equation, but still keep it equal. So for example, let's say we have this equation 2a plus 3b equals 18, and this other equation 4a plus 3b equals 15. So we know both of these equations are equal, or well, not that they're equal, it's just that both sides of the equations are equal, which means that we can subtract these equations from one another. So for example, let's write 4a plus 3b, or actually, we can just write it as is. So 2a plus 3b equals 18, and we're going to subtract the second equation from it. So minus 4a plus 3b equals 10. So now we just subtract everything like a normal subtraction problem. So let's subtract the a. So this will be negative 2a because it's 2a minus 4a. Then over here, 3b minus 3b is 0. So notice that this entire variable just vanishes from the equation. So it's like we don't need to do anything with it anymore. And finally, for this third one, 18 minus 10 is just 8. So now by subtracting these two equations from each other, we've now made it so that we have just one variable in a new equation. So that it makes it much easier to solve. So now we can divide both sides by -2 to get a equals -4. So now we've solved for one of our variables. And so now if we just, well, let me erase this. If we now just plug a equals -4 back into an equation, so let's use the first one. So 2 times -4 equals 3, or sorry, plus 3b equals 18. So we add 8 to both sides. Oh, okay. So that is just -8 plus 3b equals 18. So if we add 8 to both sides, we get 3b equals 26. So b equals 26 divided by 3, 26 thirds. So this is how elimination can be useful, because if you try to use substitution for this, you would have to do a bunch of division to try to get one variable isolated so you can substitute it in. And honestly, just no one wants to do that. So that's why we can use elimination to solve for just one variable. Okay, let's do an example. Solve this using elimination. And luckily, you don't actually have to do a bunch of manipulation to get it into a good state. Okay. I'm going to go over the question now so we don't run out of time. So, solve using elimination. This question is actually kind of simple, in my opinion. All you do is you add the equations together, like just a regular addition problem. Because why would you do that? Because there's like a minus y here, but there's a plus y here. So that means when you add them, they cancel out to nothing. So then we add everything else. So 5x equals 25, right? So then x is just 5. So now we've already solved for one of the variables. All we got to do now is just solve for y. So to do that, let's just substitute x into the first equation. So 2 times 5 minus y equals 22. 2 times 5 is just 10. So 10 minus something equals 22. So that means y would equal negative 12. So the solution is 5 comma negative 12. Okay.
Okay, what was it actually?
I was going to draw a lemon first because someone said lemonation or something. And then I was like, okay, this is a terrible lemon, so let's turn it into a car. But then I realized, okay, this is a terrible car, so let's just let everyone try to figure out what it is.
Honestly, the wheels kind of look like eyes. Not gonna lie.
Yeah, because after you said it was an eye on wheels, I added them to make them look like eyes.
Um,
Okay, third way, or this should be the fourth way, equal value method. So the equal value method uses this property. If A equals B and A equals C, then that means B must equal C, right? Because if they're both equal to A, because if B is A and C is A, then that means B is just C, right? So on that note, if we have two equations where they're both set to the same variable, like if something is equal to y and another thing is equal to y, then we can use this property. So if 3x plus 8 is equal to y and 3x plus 7 is equal to y, then that means 6x plus 8 is equal to... Wait, are you guys learning about this in Miss Richardson's class?
We've already learned about it.
Oh my gosh. Well, oh, well, then you guys should be pretty good at it then, right?
Even at homework, we should be.
Oh, okay. That's okay. This will be just review for you, okay? Okay, so then if we solve if we subtract 3x on both sides, and then we can also subtract 8 on both sides, we get 3x equals negative 1, so x equals negative 1/3. And then if we solve for y by substituting x into this equation, we get y equals 6. So the solution is negative 1/36. Okay, solve this one. And after this, is the Kahoot after this?
it should
Oh,
be.
there's some practice. So we can go to the Kahoot. Or I could show you the application of graphing.
Yes, you could do both.
Yeah. It's not a fancy application. It's just like an application.
I mean, it's better than nothing, you know?
Yeah. Okay, I'll just go over this. So since they're both equal to y, we can just set them equal to each other. So 2x plus 7 equals 5x minus 5. So then we can just solve for x. So if we subtract 2x on both sides, and we also add 5 on both sides, we get 3x equals 12, which means that x equals 4. So we have one variable already. So now we can solve for y. So let's just use the first one. So y equals 2 times x, and x is 4. So 2 times 4 plus 7, that's just 8 plus 7. So y equals 15. So the solution is 4, 15. Okay, quick side note on an application. Okay, this is an application of graphing, and I like this application. Basically, you don't really have to understand it. All I did was I was testing the salinity and resistance of a circuit, and I did this several times, and then I graphed them to try to see which one I should use. And this is why graphing is useful, because it can tell you what stuff looks like. And so you can see they all sort of like intersect up here, and then they kind of curve down over here. So this is an application of graphing. This is also what I was doing before I came to this class. So yeah. Okay.
If anyone has any questions, ask them now. Otherwise, we will keep it. And I think it's not for science fair, but like,
Nope.
science
Could
lunch.
we do that? Could we do
It's-
the Kahoot instead?
What?
Should we do Kahoot instead of practice?
Oh yeah, we are doing the couple.
Yeah, we're doing Kahoot.
Wait, Amy?
No question. Okay. If there's no questions, I'll just set up a Kahoot. Oh, am I? Wait a second. Let me stop sharing and make sure I'm sharing with sound.
Oh wait, what
Oh,
did
no,
you
no,
use
no.
Bearbucks for? Just curious.
Wait, what?
Bearbucks. Did we have them?
What? The
Bear
middle
bucks.
bear? What?
Bear bucks.
Bucks.
What is that?
It's nothing. They're just like paper money, and then they're for like every different team. So the innovators are doing it now, and
Oh.
I think you can buy candy or stuff.
Oh. We had this thing.
Oh,
in
we
middle
had the
school.
little point system.
Yeah, we had the point system, and you could get like 1,000, and that would be
fair.
2 points basically.
That was
Just
the
that.
dumbest. Oh my gosh, we had that in 7th grade and 8th grade.
Apparently,
Oh my
that
gosh,
site
in
sold
8th
your
grade.
information or something. But like,
Oh. Well.
something. Yeah. Or that was a thing people said. I'm actually not sure that is.
Okay, here's the chat. Or, sorry, code. Wait, can you hear the music?
Yes.
Okay, that's nice. Music? I think music is a big part of Kahoot.
Yeah, it's like the biggest annoying factor. It's still
I think the Kahoot music is interesting.
well, I do not like it. I like the Halloween sounding one.
Okay, then we can change the music. Oh, we can choose a new theme song. Oh, I see, like, some of these are just done.
Also, who put my name? Like, that actually was not me. Like, I would just like to clarify that is not me.
Okay, wait, are you guys happy with this music, or do you want a different one?
It worked.
It's okay, but it's a lot distracting. It's good because she didn't turn it up.
I'm gonna play this. I'm gonna like. This is really annoying. What is this?
Someone asked for you to do trends.
Okay. This one is interesting. Okay, this one. Do we have a consensus?
Two
No.
people want it.
Bro,
Two people.
Miss Cabral plays this in
This is
Oh,
very
yeah.
annoying. Which
It's
one?
the
Okay. I'm
The
sorry.
one I
Christmas.
like for Christmas.
The Christmas one is chill.
It's a jingle bell.
Okay, I'm gonna start. I think we can change the music along the way. I hope.
Hopefully.
Okay, what's the solution to this system? Oh, it doesn't.
Green.
I can't change the music. Dang, I can't change the music anywhere. Oh wait, yay! Everyone got it right. So yeah, the solution is just the intersection. Still can't change the music. Okay, in first place we have Aishwarya, then Brian O'Toodles, Candy, you, and Anand. What is the solution to this system of equations?
Yeah.
None of the solutions are right.
Yeah, they are.
No,
This
there's
is.
-2, 1/2.
Uh-oh.
Well, no. It was. I think
Actually-
the crux was just moved up because, like.
Yeah, I think this was just moved up on accident. So like this is 1, this is 2, this is 3, because the 1 refers to this one down here. It's just everything was kind of shifted in the picture. Okay, what is the solution to this system of equations?
Blue.
Q4.
Okay, all you guys got it right. What is the solution to the system of linear equations?
That took me too long. Probably getting like 6th or something. Yep, 7th.
The solution, or this system doesn't have a solution, and the reason is because they have the same, these lines have the same slope. In other words, they're parallel, so they'll never touch, which means that they'll never intersect, which means that they don't
That
have a
was too
solution.
small to read. You would have to infer that.
I mean, well, okay. Also, here's the thing. If they have the same slope, technically they could be the same. Like they could be infinitely many solutions, but they would also have to be the same line, right?
Yeah.
So keep that in mind.
Okay, what is the solution to this system of equations?
I assumed it would be blue, and I hit green somehow.
Okay, so this would have infinitely many solutions. And if you notice, these two equations are actually the same line, just in different forms. And these lines are laying on top of each other, which means that any point on one line is always going to be a solution, like a point on the other line, which means that there's infinitely many.
Just saying, there's a way of making the screen bigger of this sharing.
Technically, wouldn't there be like 2 solutions?
Oh,
Yes, you should.
technically, yes.
Yeah, but like first thing that should come.
It's really. Yeah.
You just graph it.
What?
Okay.
Why would it not be
There's no
elimination?
solution though.
Wouldn't it be elimination?
No, it
No.
would be graphing. It would be graphing because you can't have a solution, so like that would help. It would be anything.
Technically, any of these could work, but if you were to solve this, probably I don't think graphing would be the best way. Elimination.
All of them
I
would
mean,
work because it's easy to do all of them.
yeah. I mean, I would personally say, like, the most obvious way to me would be equal value method because they're both set to the same variable. So,
Yeah, for
Yeah.
me, it
Yeah,
would
but
be
that's what-
elimination. Because,
yeah, elimination would probably be the easiest, though. yeah.
yeah. And you'd get no solution, which is that.
Yeah. What is the solution?
Green.
Well, we revealed it earlier, but you know.
It didn't work. It wouldn't let me click the screen for a solid 8 seconds, like 5 seconds.
Okay. So if you use elimination and subtract these equations from each other, you'll get 0 equals like 55 over 6. That's not true. So that means there's no solution. If you use substitution or equal value method, you get 0 equals something that's not 0. So again, that wouldn't be right. So
Also, they both have the same slope.
yeah, they have the same slope, but they don't have the same y-intercept, which means that they're parallel, but they're not intersecting. Oh, double points. Wow.
Green.
What is the solution?
If we could
Oh,
see that
golly.
in the question, that would be nice. Yes.
It's not too lazy. And I realize I'm wrong.
Oh, interesting.
I think a lot of you just didn't simplify for your x value because.
Yeah, you do need to simplify. Yeah. I'm not going to solve this. There would be a lot of writing. Okay. This is the last question, though. We still have 15 minutes, though.
Do we have another
Okay.
Oh,
Okay, in third place we have Aishwarya. In second place we have you. And in first place we have Candy. Who's Candy? Oh my gosh, Ashani, you're Candy?
yeah,
Guess who you is?
I do not.
That's me.
Oh,
Okay.
I was just like, why am I being beaten by someone else in the class?
Okay. So the final standing is Aishwarya, then Advika. Who's Ishani Tarkar? Like
I think
the
it's
one who's
Jay.
named.
He said
Jay?
he-
Okay.
Yeah.
So it's Aishwarya, Advika, Jay. Okay. No, at first I was like, someone actually beat me.
I was
And
like,
then I was like, yeah.
I was like, why is someone beating me throughout the entirety of the thing?
Yeah.
Yeah,
I was like, and then at the end I was like, how did someone beat me? And then I was like, oh wait, that's Ishani. Okay. Do you want to do another Kahoot?
I can do a random Kahoot and you can stop the recording.
Okay.
Stop the recording first. Because, yeah.